So we have our equivalent capacitor, and then we've also calculated what the energy is. So what I'm going to do next is that, so let me just show you what we're going to do next. I want to calculate E1. So what is the energy E1? What is the energy E1 on capacitor number 1? Then I'm also going to calculate what is the energy E2 on capacitor number 2. What is the energy E3 on capacitor number 3? And what is the energy E4 on capacitor number 4? Now, if I can do that correctly, then I can add E1 plus E2 plus E3 plus E4. And what do you think that should give me?
2.04.
It should give me 2.04 times 10 to the negative 4. So that's how you can double check to make sure that your answer is correct. So the total energy in each of the capacitors must be equal to the 2.04 times 10 to the negative 4. Okay, so now, so we need a new screen here. So I'm going to go ahead and open a new screen. So we've already calculated, so I'll just go ahead and draw a quick picture here. Okay. So again, this was C1, C2, C3, C4. And we said that so we can reduce these. So we can reduce all of these into C equivalent. Where in this case my C equivalent is just equals to 2.84. 2.84. Now, since I know my C equivalent, let's go ahead and calculate the total charge. So the total charge is equals to C equivalent. Now, if you substitute that value, you should get 34.1 microcoulombs. So if you just take 2.84, you multiply that by 12, because delta V is equal to 12, you should get the total charge. Now, so it's a little bit confusing, but you need to, so if you think about it carefully here, if you want to think about this in terms of current, so if current comes in like this, then the current at this point is going to branch. So current is coming in here, is going to branch into two parts. One part goes up, one part goes down. But by the time it gets here, the current is going to recombine at this point and everything. So what I'm saying is that the total charge is also the same charge that goes through C4. So I'm saying that Q4 is the same as Q. So the total charge in capacitor number 4 is also 34. And so with this, I can calculate my E4. So my E4 is equals to 1/2 E4 squared. Now, if you do this correctly, you should get, I'll just write it as 0.725. times 10 to the negative 4. Now again, remember that when you take Q4 squared, you need to convert that into, so you need to take 34.1 and multiply by 10 to the negative 6 first before substitute. Okay, so since we know E4, does everyone agree with that? How we calculate E4? So since you know E4, I can go ahead and calculate, so I know that Q4 is equals to C4 times delta V. So from here you can calculate delta V4. To do that, you should get 4.26 volt. So 4.26 volt is the voltage across capacitor number 4. Now the way we can look at this is that call this point A, and call this point B, and call this point C. So I'm saying that the voltage between this point and this point is equals to 4. So 4.26 is the voltage between point B and point C. Now, if 4.26 is the voltage between point B and point C, then it means that the voltage between point A, so this is point A here, the voltage between point A and point B must be equal to 12 minus 4.26. So it's the total voltage minus the voltage across C4. So you can calculate, for example, so V3, let's see. Delta V3 is equal to delta V minus delta V4. This should be equals to 7.74. So that's the total voltage across C3, which is also the voltage across C1 plus C2. So now, since I know delta V3, I can calculate E3. So E3 is equals to 1/2 C3 delta V3 squared. If I do this correctly, I should get 0.6 times 10 to the negative 4. Now, I can go ahead and calculate. So what is the total charge on capacitor number 3, Q3 is equals to C3 E3. If you do that correctly, you should get 15.5 microcoulombs. Now, notice that Q3 is also the same as Q2, so Q2 is equal to Q3. Why is Q2 equal to Q3? Because C1 and C2 are connected in series, right? So the charge would be the same.
You put Q2 and Q3, not 1 and 2.
Say that again.
You said how C1 and C2 are.
I'm sorry. That's my mistake. That should be Q1. Let's see. I need to take this back. So let me take that back. So Q1, sorry. So Q1 plus Q3 must be equal to Q2 row.
Will the delta V be the same for 1 and 2 as it was for
No.
3?
So delta V1 should be different from delta V2 because C1 and C2 are in series. So from here you can calculate Q1. So Q1 so PQ was equal to base, so Q1 minus Q3 is equal to 18.6. So because Q1 is equal to, so Q2 is also the same as Q1. So now since we know Q1, we know Q2, I can go ahead and calculate my E1. So my E1, for example, I can use this equation here is Q1 squared over 2C1. It should give me 0.431 times 10 to the negative 4 joules, and then your E2 equals E2 squared over 2C2. And if you do that correctly, your E2 should be equals to 0.29 minus 10 to the negative 4. Now, if you go back and add all of these, so take your E, so this is E3, and then this was E4, and this is E1, and this is E2. So E1 is 0.431 times 10 to the negative 4. E2 is 0.29 times 10 to the negative 4. E3 is 0.6 times 10 to the negative 4. And E4 is 0.725 times 10 to the negative 4. If you add all of that up, so if you do E1 plus E2 plus E3, you should get, so if you add E1 plus E2 plus E3, this is what you should get. You should get 2.04. To the negative 4 joules.